Sulphuric acid is one of the most important and widely used products of the chemical industry. It's produced in large quantities because of its highly diverse use, including production of paints, detergents, textile industry, production of medicines, and in metallurgy processes. There's a wide range of procedures that facilities operating with sulphuric acid have to follow to obtain required permits, primarily to mitigate risk for the employees. Engineering principles of handling sulphuric acid are established, proven, and widely applied. In Southeast Europe, more than 6 million tons of sulphuric acid is used annually, whereas in West Europe, for instance, Germany alone uses 7+ million tons of sulphuric acid per year. Yadar will be an integrated mining and industrial project, using 320,000 tons of concentrated sulphuric acid annually in the Yadarit ore processing. Sulphuric acid will be transported by specially designed, dedicated train wagons. Transport from unloading from train wagons to storing to using the acid in the process is performed in a closed system, equipped with accident detection and automatic pump shutoff systems. The unloading technology will be without opening a top lid to protect employees and prevent physical contact with sulphuric acid. Sulphuric acid is then stored in closed and isolated vessels at the location of the processing facility complex and used mainly in the digestion process. About 85% of the sulphuric acid brought onto the site will be added to the digestion process in a controlled manner to dissolve the lithium and boron contained in the yadarit. 85% of the sulphuric acid consumed within the complex is used to dissolve yadarit in a controlled manner, whereby sulfate salts, lithium sulfate, and sulfates of other metals are formed in the reactions of acid and minerals in the yadarit concentrate. These reactions consume the sulphuric acid. The liquid in the digestion process will be controlled to have a sulphuric acid concentration equivalent to a pH value of 3, with the ore dissolution process being carried out at a temperature below 100 degrees Celsius, which is significantly below the 250-degree boiling point of sulphuric acid. The off-gas generated during the ore dissolution process will not contain sulphuric acid fumes. It is important to know that the digestion process cannot and does not generate sulfur dioxide gas. We can say that no sulphuric acid vapors nor sulfur dioxide gas have been detected in pilot tests and numerous safety and hygiene checks in the work environment. As an additional protection measure, Venturi scrubbers will be installed on the digestion process off-gas, which will neutralize any dilute sulphuric acid mist that was to find its way into the off-gas. It is important to understand that in the further process after the yadarit digestion, alkaline chemicals are added to the process solution, which raises the pH to an alkaline value of 11.5, which completely decomposes the small amount of residual sulphuric acid remaining following digestion. So you might ask, what has happened to all the sulphuric acid that is added? Its components are ultimately converted within the process into a range of benign compounds such as water and gypsum, or saleable boric acid and sodium sulfate products.